This problem is fairly simple once you realize that it's all about the graph and the fact that when you are taking the area under a force versus position graph, that means you're talking about work. So work equals force times distance, or in this case, it's going to equal the area under that curve, which is 1/2 times base times height. You also need to remember the work energy theorem and know that work is equal to whatever change in energy you have. In this case, since we have an object that's at rest and then acquires a certain speed, then what this means is that it's going to be our change in kinetic energy. So we can calculate our work. That will give us a change in kinetic energy. The change in kinetic energy is just going to be our final kinetic energy minus our initial. Since we started off at rest, K naught equals 0, so we can cancel that out. And K final is going to be 1/2 mv squared. We have our final velocity of 3 meters per second. We have a value for K, which is 1/2 times base times height. And that is going to be equal to 1/2 mv squared. And we can now solve this for m. We can cancel out anything that's on both sides, which means that the 1/2 can go away. We can also go ahead and divide out the v squared. And when we do that, we're left with, and I'm just going to move over to the left, m equals bh over v squared. If we do that, it is the base times the height, so that is going to be 0.090 meters times 3 newtons divided by the velocity squared. And the velocity squared is 3 meters per second squared. Then all you have to do is plug and chug that into a calculator. When you do that, you should get 0.03 kilograms, which will give you an answer of B. If we look at the answer key, we will see that the answer is B, and indeed that you do need the work energy theorem in order to solve this.